So the way you're going to get that far, is you're going to clone this thing off PDX-CS Rust. Now, you may wonder what PDX-CS Rust is and why. That's an oddly what's the word I'm looking for? Specific name for a thing. I hate you, I hate you, I hate you. Okay, there we go. Browsers are terrible. This is a repository that contains sort of the accumulated code from all the offerings of this class so far, and I'll be adding to it throughout the quarter. You should be aware of its existence. It's linked up in the Moodle. And you might dig through it. We'll be using things out of here quite a bit. We'll be adding to it as we go. But one of the things I put in there was this assignment. Why do I have an email that doesn't make sense? I don't know why this box. Oh, it's that uploaded box. Nice. So, we clone this. Now we got a copy of the assignment. Let's take a look at what we find in there. I don't think we walked through this last time, right? We're out of time, I'm correct? Yeah, okay. So, this is the file you'll be editing. And you'll be editing it to implement a bunch of functions. The functions compute various statistics. Probably the easiest statistics is the arithmetic mean. Statistic is the arithmetic mean. And the arithmetic mean is a function, as you know, of numbers, and it takes a bunch of numbers. In this case, we've chosen to use numbers of type F64. Who knows what an F64 is?
64-bit floating point.
64-bit floating point, specifically 64-bit IEEE floating point. So this is, what's the name of that type in C? Double, right? It's a double precision floating point. Double what? Well, double single precision. Well, why is 32-bit single precision? Because it is. So rather than use dumb names that only make sense in a really, really historical context. By the way, it's single precision because it fit in a single word on the VAX or something, on the PDP-11 or something. So,
it's 4 bytes.
you know, rather than go there, we're just like, no, you know what? This is 64-bit floating point. And these days, that always inevitably means IEEE 854, 64-bit floating point. So this thing takes an ampersand square brackets of floating point numbers. An ampersand square brackets of floating point numbers? That's a weird thing. It turns out that's an address, a reference, like it would be in C++, to a sequence of some kind of floating point numbers. It's an address to it's the address of a bunch of floating point numbers stored sequentially in memory. How many? It also, that reference implicitly has a length associated with it. This isn't C or C++ where you have to pass the floats pointer and the end floats. And this isn't C or C++ where you just walk off the end, the rest runtime checks will stop you from doing that. But this is basically a pointer to a bunch of floats together with its length. That's what nums is. So I have this thing kind of like an array that I pass in, and what I'm going to return is an option F64. Option? What's an option? Well, if you look at the homework write-up, it kind of tries to explain what an option is. Rust uses the option type a lot. It's one of the most common unusual types in Rust, libraries and code. It's a very useful abstraction. Now the mean is really well defined for anything, right? If I take the mean of an empty list, What should the mean of an empty list be? Oh wait, I have a test up there. Look at that. So, well, I have a document that describes it. So this is kind of interesting. This is a thing. We have what's called RustDoc. So just like Java, just like a million other languages, we have this thing where you can put comments in with a special comment indicator. And that can be automatically compiled out by a program called RustDoc into documentation for your stuff. And in this situation, the documentation, right, describes what this function does. It computes the arithmetic mean of the input values. It explains that the mean of an empty list is 0, right? And then we have this example section, hashtag examples. The dot comments in Rust are written in markup, in Markdown, I mean. And they're Markdown comments, literally. So if you follow the Markdown specification, the right thing happens. So what we have is a section header, examples, colon. And we have then some code fences, the triple back quotes. Then we have some code, which happens to have a line that's sort of semi-commented out with hashtag. I'll talk about that in a second. And then we have some code that's an example of the Rust. And so if I format this with RustDoc, I'll get a nicely formatted block that has an examples section and then has code blocks with the examples. I guess the easiest way to show you that is to show you that. I don't know why I'm talking through it. Let's see what happens when I RustDoc this. Should have opened it somewhere. It says it opened it somewhere. Where did it open it? It's like, okay. Oh, maybe it, interesting. It maybe try and document the binary trait, not the library trait, maybe? I'm a little confused. Why doesn't dash open a thing? It's gonna be one of those days again, isn't it? Okay. Let's do it a different way. In the target doc directory is your thing. What is this called? Stats. I have no idea why you open it before. Anyway, this is the documentation it produces. And if I click on the mean function, I can see what happened here. If I make the font big enough, which is that doc comment I put in there expands like this, and I get this nice examples section, and the examples themselves are in code blocks so that I can see what's going on. Yeah? I'm not just telling you this as a point of information. I'm telling you this because I expect you to be doing this in your code. It's pretty much a requirement in here when you do code. You know, that you add dot comments where appropriate. That's a thing in Rust. I don't consider the code done until it's been documented in this way. So, and it's neat that there are these runnable examples. And you'll notice that the use declaration I needed to make this work, or wanted to make this work, it's commented out, so it doesn't actually appear in the block. Well, then why would I put it there at all? Oh, because it turns out that stuff inside the code fences is also treated as a test by Rust. That is, when I say cargo test, it will actually pull that code out and put it in a separate file and run it. And the test is considered to have passed if the code doesn't crash and panic, and it's failed if it does panic. So right now, the code is unimplemented. The function's unimplemented, which will actually cause the program to panic if it's called. Let's demonstrate that. Well, we have a nice empty file. It compiles it, and then it panics. Not implemented, no mean yet. So if I say cargo test, it's like, boom, none of the tests pass. It's like they all failed. Well, wait a minute, I didn't write any tests. Yes, you did. You wrote documents that had examples in them. And so this example section is special, and these code blocks are special, and they're both documentation and tests at the same time. And that's pretty cool. What that means, just a sec, what that means is that the examples in your docs should never go stale, because if they go stale the next time you run cargo test, it's like, oh yeah, you know, these documents don't work. That's pretty unique. That's a pretty cool Rust thing, yeah.
So before you would just write a specific, like a specific like set of test assert equations, and then you just run that with cargo test. Is this the new way of doing that?
This is another way of getting a test into your Rust program, yes. Another way to get tests into your Rust program would be, where's my mean here? I lost it. There it is. Would be to do something like this. Say test and then write a function. And so we'll write a little function here that tests whether a single value is its own mean. We hope the answer will be yes. Note the assert eq macro here. This is assertions like in any other language. Says if those two things aren't equal, crash, panic. Not crash, but panic, and stop the program. Otherwise, go on as if nothing has happened.
So it doesn't run all of your tests if one of them fails?
No, it did run them all, and they all failed. There's no tests that pass it. It doesn't run them in any particular order, by the way, so please don't write tests that try to count on that. They're literally running separate processes, so they don't have any communication with each other. Yeah. But, so I can also write a test like this. That's another legitimate, kind of test to write. If I say, that won't appear in the documentation, obviously, but if I say cargo test, then, look, it failed, because mean isn't implemented yet. Yes. A third way to put tests in your program, let's see, is to make a test directory. And put test functions in there, in files, source files in the test directory. Let's see if I can get this right. Let's just go nuts here. Probably won't. One of the things you gotta be careful of with tests involving floating point is they actually produce the right answer. I know this will produce the right answer. I said 100 in the name, say 100 here. That's bad naming. So now I've got, a test there. Let's see if it'll run it. I forget if I need the test keywords to do this because I never do this. Oh, right. I need to, in the source file, do my use declaration here. There we go. And hey, guess what? It doesn't realize it's a test, so I still have to put the test declaration here. There we go. And hey presto. That's odd. Apparently these tests are run first. not quite sure. I guess the the stuff in the test file is run first. Anyway, that's another thing. Test means singleton, blah. Anyway, so yeah, a lot of tests can be written and run here. There's a lot of ways to do it. Again, I'm not telling you this out of idle curiosity. I'm telling you this because I sort of expect in CodeUWrite, you'll insert appropriate unit tests. We make it very, very, very convenient in this language to insert appropriate unit tests. So now, go forth and insert documentation and unit tests. That's a part of the Rust programming experience. You should start it from the very beginning. It will take a little getting used to, and then you'll be very, very happy that you're doing it. It will catch a lot of mistakes. Anyway, the point of this, to some extent, was the option type. So I have this fancy type declaration up at the top. Let's talk about the fancy type declaration for a second. It's pub here. So let's go back a step. Sorry. I have a whole bunch of detailed notes about what I'm going to talk about today. We'll get to them soon enough. Let's see. So this is the package file, and you'll notice there's nothing interesting in it yet. But what we said before is this thing actually builds two things. It builds an executable program called stats, and it builds a library called stats, a library crate called stats. So we say it builds a binary crate and a library crate. And we know it builds both kinds of crates because if you look in the source directory, there's a file called main.rs and there's a file called lib.rs. And so it will happily build both things. We could actually fill this out if we wanted to make it more obvious what's going on. Right, this is implicitly in your Rust doc at this point. Oh, that should be main.rs. There we go. Let's see if that'll still build. I think it will. Yep, perfectly happy. So the point is, this is all implicitly there. We're implicitly building a binary in a library. It's just that if you name things and structure them the way that Cargo expects, you don't have to put this extra boilerplate in your TOML file. Yeah.
Why do you have double brackets around binary?
Because that's how Cargo works. There's no very good reason for this.
Okay.
It's kind of dumb. TOML is a language that is a format. I say language. It's a file format that precedes Rust. It's a pre-Rust file format, and it's sort of a very, very cut down version of YAML, which is good because YAML's insanely overcomplicated and ambiguous and kind of a mess. But it still has some of its YAML history, and it just turns out that because of the way the file is structured and read, you need 2 square brackets around good and 1 around good. Yay, arbitrary rules. There aren't very many of them in Rust, there's a few. You can have multiple binary crates be built from a particular Cargo repository. You can have only 1 library crate. That's all you get. So, if you want separate libraries to be built, you have to have separate TOML files and separate the whole thing. Anyway, so the point was going to be that lib.rs is the library crate source, right? This is building a whole separate artifact than main.rs, right? Main.rs builds a binary that depends on the library. Lib.rs actually builds the library. Pub in this context means outside users of the library will be able to see this symbol. It's just like the visibility control in C++ or Java or whatever. Except by default, things are invisible in Rust until you make them visible in Pub, because that's a way more sane people client. That's what we do with Nickel too. And So we're saying, well, this type, people should be able to see that type, stat thing. What is that type? Well, it's the type of functions from these, array references to arrays of floating point numbers, and returning an option F64. Oh, wait, mean had that declaration, right? And that's not a coincidence, right? I'm gonna make all these stats functions I write have the same signature, have the same type. And that way I can, play games, the caller of this library can play games about not worrying about which one they're calling, right? Does this one ever return anything but a number? You just make them all the same. So that's what I chose to do here. It's my code. I can do what I want. And, but for the mean, it's kind of pointless because the mean never is going to return none. But notice what it does return. It says, well, if we call this, we get back this. We get a value of type, a value named sum minus 1.0. Really? What? Well, there's two kinds of option values. Option is a type, and option here is an option F64, meaning that it wraps an F64 somehow. And so the values of type option F64 are none, or sum of 1 minus 1.0, or sum of 0.0, or sum of really any other floating point type, right? So what does this remind you of in C or C++? What does this feel like there? Null, right? Would be one example. Oh yeah, it's a pointer type. Oh, except when it isn't. Except when it's actually set to null, whatever the heck that means, or 0, which is null, and blah blah, right? Have people heard that there might be issues with null pointers?